Hello guys and welcome to a new YouTube tutorial. So first of all, if you want to contact me, I got a homepage. Just click here on contact and then you can fill out this form here. I'm on Twitter, Instagram and Patreon for exclusive tutorials. And there's one thing on this Sunday, so tomorrow. There will Houdini Battle on number 14, and I will compete or try it against three other great artists, and every designer got an hour, and yeah, we will see how that will turn out. So you can attend here online via Meetup. I will leave you the link in the description. So today what we will create, or what we will do, the simple rigid body simulation here, and here are some style frames, for example, shaded a little bit differently. So I used Quixel for that. The gemstone pack here, they got a few nice meshes in here. Let's quickly get a look at them here. Mesh 2, mesh 3, mesh 4, mesh 5, mesh 6. So cool meshes there, scanned meshes. Check them out. Of course you can also use, what I will try next is maybe with some bones or with the mushrooms here. So I think there are really a lot of nice possibilities. Also I think the scattered rocks are pretty cool, so you can try them out here. And yeah, I use them and then throw them together for this animation here. So pretty simple, pretty nice to do. You can maybe make some speed ramps in here in compositing or in rendering, so you can, for example, retime the simulation, and you will end up with something like that here. Of course, here is a little bit of noise in here, but that's just for demonstration purposes. Yeah, so for example, you can shade it like that. I manipulated a little bit the shader, but not much. So just like a tinted glass material, composite that a little bit, multiplied it with the overall color, etc. So nothing complex. So for the setup, let's start with the setup here. So what I did, when you got the Megascans plugin, you can just directly export from the bridge. So if you download something, you can directly export it. Let me just show you it here. Gemstone pack. Where was it? That one. The pack here. Then you got your. Let's just disable that. Then you got your Megascans plugin, and you can choose your renderer, your desired, so Mantra, for example, Redshift or RenderMan, and then you can simply hit export here, export to Houdini, and the bridge will automatically create a subnetwork with two other nodes. The material network node for the material, and then the LOD1 for the stones. So you got here different stones, of course you can do Shift L. You got here the different stones, so they're currently in a pretty low resolution, as you can tell, so 4600 kind of polygons or primitives. You can choose here on export settings models high poly source, and then you will export a high poly source. You can do that of course too, but for a faster simulation you can use that, or of course you can later transform by pieces, and extract transform. You can basically transform the high poly onto the low poly. So this is like our mesh here, so crumbled together. And what we will do, we will merge them together again. So let me just give you a quick breakdown here. It's not that hard. It's pretty simple. So we got a merge here, so we will merge all rocks together, and we will place down a connectivity, and the connectivity will give us a class attribute, and with this class attribute we can differentiate between those rocks with an attribute. And then we can use an attribute from pieces to randomly assign a variant attribute for our piece by the copy to points. So we will copy a different rock onto each point. There was other methods in the past with a set variant and get the variant from the assemble node. You can of course do that too, but the node is here and why not use it? Then simply delete some attribute, assemble them all together in packed primitives, then basically simulate them here. Nothing, really nothing fancy. I used the pop attract node here, for example. Unpack them again, and then you're ready to go. So, and of course here the little bit of point clouds, initialization, randomize, p-scale. Yes, so that's basically it. Okay, so let's do that. We got here our stones. Let's disconnect them. Let's delete the other pack here. Let's view them. So we got our stone pack, and the first thing what we will do is merge them together. So you can place down a merge, and let's lay them out here. You can do it like that here, or a quick shortcut is to just select them, click Alt on your keyboard, and just drag and drop from the little output icon here with Alt click, and you merge them all together. Now we got already I think on class attribute up here, yes, but we'll delete that. Not agent, attribute delete. I will just delete that for now, because we will make an own. So connectivity, of course you can use it, but yeah, let's use an own here. Get it on primitive, and you can call it whatever you want. That's fully up to you. Let's leave it like class. Okay, we got our merged crumbled stones here together. What we want to do now is to copy them on points. what we need for that, we need points. So let's get a sphere here. Let's get a polygon. The primitive type on polygon, for example, it's of course not unnecessary, but you can do that. For the radius, you can basically choose whatever you want. I will go a little bit flatter in the y-axis, and after that you can simply place a VDB from polygons. Let's place that. Let's go to density type, voxel size, maybe 0.01, to just make it a little bit denser. After that, I want to place a scatter node. So we will scatter points into the fog volume. And for example, let's go for 25 points here, just for the beginning. So I want to randomize the rotation, and the quickest and basically easiest method or way to randomize your rotation on the copy to point node is basically the normal. So attribute randomize, and we will not currently the color here is randomized. We will not randomize the color, we will randomize the normal vector, and we will choose inside sphere. And now when you enable display normals, you can see the normals got a different rotation, and under options you can change the global seed, and you will see that we will each time we will play with the seed or change the seed, we will get another direction, and that will come in handy when we will copy our stones. Cool, we got that. Let's go back here on FreeF. So we got our points. Now we want to randomize our scale. There are several nodes to do that. For example, there is of course the attribute randomize node. So what you can do here is attribute name pscale. So set pscale. Pscale set rand rot rotation, and you can go for custom ramp, for example. And let's get a copy to points here. Copy to points, and let's just use them as crumbled rocks together. So you can now see we've got a different scale and a different rotation. So different rotation, different scale. For the scale, there is also an attribute adjust float. You can try that out too. It's already initialized by pscale. What you can do, you can set initial pattern type random, for example, and pipe that in here. So that will do basically the same thing, but you can adjust it a little bit more better here. So you can, for example, dial up the max value to 2 and the min value to 0.85, for example. And then also there is a global seed. You can use like a custom attribute, for example the ID. If you don't got an ID, you can just enumerate the points here. Points ID. And let me just show all attributes. ID should be fine. Yes. And you can use, for example, the ID here as a custom attribute or just the element number. So that's basically fully up to you. Okay, now we got our copy to points, and for example our adjust attribute float with the p scale, or you can use set p scale, or you can use an attribute wrangle for p scale with, for example, that little function here, nothing fancy, but it's all basically the same. So for like a fast workflow, I would for just doing R&D, don't hassle too much, just do it. So just get, for example, attribute randomize or the attribute adjust float, and you're done. So what we want to do now, we want to get here the attribute from pieces. So attribute from pieces, really nice node. We'll need a point cloud. So the point cloud will be our scattered points in from the volume, and then the geometrical or the geometry library. So we got here different pieces crumbled together. And now what I want to do, I want to get the piece attributes to the class, and the mode I want random. And let's connect that to our points here. And what I want to do, I want to set the piece attribute not to variant, I want to set it to class. And now you can see we will copy different geometries from our geometrical or from our library on the points. So I think that's really handy, and you can use it for a lot of things. For example, let's just do other library. Let's get here a sphere. Let's get a torus. Let's get a platonic solid. And let's copy that again. Make it a dodecahedron. So those four pieces, let's merge them together and pipe them in here. And you will get basically you will get the same thing. But now currently the p scale is way too high. So let's just transform them here smaller. And now it's basically the same thing, but with other geometries. The cool thing is you can also do piece weights, so you can get your autofill in here, and you can place a certain weight onto the pieces. So that's pretty handy if you want to determine the weightness or the distribution of one piece. So you can, for example, let one piece dominate here our scene, for example the spheres. Or if you want the dodecahedron to dominate, you can do it like that. I think that's pretty cool and can come pretty handy. And of course you can just use the uniform attribution. You can make your own weight attribute, or you can just piece weight autofill, and then you're good to go. So that's also pretty cool. And you of course can play with the seed here. You can get it a noise in, you can do it random, you can make an attribute, you can make an expression, you can do patches. That's also really nice. If you wanted to patches, you can play with the patch size here. For example, let's get that smaller. For example, like that. So I think that's a really nice node, and it's First of all, it's built in. Second, it's fast, and third, it's really easy to use and a lot of fun. Okay, so let's dial it down to maybe 30 points, and let's get our other library back in here. And we can scale up the P scale a little bit here. And let's get away from the 0 seed here. So that's looking pretty good. Now pretty easily you can basically attribute delete everything you don't need. So attribute delete. I will not use point attributes, and I will not use detail attributes, for example. Then we can place down a null here. Out, let's call it for sim. Then a simple assemble node here. Let's create pack primitives. And then basically already bullet solver. We will use the subsolver. Of course you can also build up your own. And for example, for the forces I will disable the gravity. So currently if we will play that, nothing will happen. If you enable the gravity minus, oh my god, 9.13 I think. Of course the rocks will fall down. You can, for example, place down a ground plane here and make like a normal RBD simulation, and that's fully cool. That's up to you. And what I did is basically disable the gravity. On the pre-solve tab, I think it's mentioned here, yes. On the pre-solve tab, wire pop forces into pre-solve to apply per point forces. So for example, we can get here a pop wind and send our rocks flying. That's again fully up to you. And what I did basically was the pop attract with acceleration method, and the force scale is to I think 0.35 or something like that. And then just play it back, and there you have it. Now you can, what I like is to play with the time scale. So to get a little bit of slow motion involved, and then you can speed it up, for example, of course, in the rendering process, in your compositing process in Resolve, After Effects, Nuke, etc., or in a cutting program like Premiere, Resolve. And the cool thing is you can play with the time scale afterwards, so then you can get here a time warp node, for example, and play with that. And then in the end you can just unpack it and go with your rendering. So what I did basically was pretty simple. I got one light here. I got one light and I changed the material a little bit. Nothing fancy, I think I already explained that. And then you will get, yeah, something like that here. For the next tutorial, maybe we can do like then this look development and experiment with other type of forms, so not rocks, maybe do something a little bit different, and yeah, do shading, etc. So I think that's cool for the first part, and I hope you liked it and enjoyed. And yes, wish you a great day, keep safe, or stay safe, and I will see you in the next tutorial.